Let's consider the domain and the range for these rational functions because they have those points that don't exist. And this is different maybe than some of the other functions that we've looked at. So remember that the domain is all the possible x values that anybody could put into your function, and the range is all the possible y values that could ever come out of your function. Now, we need to define a few terms. A vertical asymptote is an imaginary vertical line that the graph never touches, and it's usually written as that dotted line. That's the de facto way to notate a line that doesn't exist, is to do it as a dotted line so that readers of your work can know that it's not there. Now, a horizontal asymptote is simply an imaginary horizontal line that the graph is never going to touch. Now, vertical asymptotes happen where the numerator equals a number, but the denominator equals 0. So you know in this family of functions how we tend to have something like y equals 2 divided by x. Well, as long as there's a number in the numerator, that works. But when you have a 0 in the denominator, because you can't divide by 0, you're going to have a vertical asymptote. Now, if you had a 0 in the numerator and the denominator, this causes a different type of problem, not a vertical asymptote. So vertical asymptote is just where you have a number in the numerator and a 0 in the denominator. Now, horizontal asymptotes are a little bit more involved. Notice how I wrote x divided by x squared. Let's think about what happens to that as x gets really, really big. So as the numerator gets really, really huge, the denominator is getting squared. So it's going to be really, 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 really huge. So notice that any number you put on top, the bottom is going to be a lot bigger. Well, as the bottom is getting bigger faster, it's creating a smaller and smaller fraction, and what you have is an asymptote right on that horizontal line y equals 0, which happens to be the x-axis. Now, if you feel like remembering this, I can cough up some extra credit. But if the degree of the numerator and the degree of the denominator are the same, notice I've got a squared term on top and a squared term on the bottom, then you're going to have an asymptote at the ratio of those leading coefficients. So that's just an interesting tidbit. When we look at rational functions, you're going to notice that the asymptotes will follow the vertical shifts. So let's take a look at f of x equals 4 divided by x minus 1 plus 1. Now, to figure out the domain and range, start by assuming that the domain can be everything and that the range can be everything. Now we need to ask ourselves a question. We need to say self. What values cause us to try dividing by 0 or taking the square root of a negative? This is the most straightforward way to figure out your domain, because these are the only two problems we tend to run into in high school Algebra 2 with all of our real numbers. So we just stare at this and we say, what's going to give us a 0 in that denominator or make us take the square root of a negative? Now, negative square roots are not a problem here because we don't have any, but if I put the number 1 in for x, I'm going to have a 0 in the denominator, and that's not going to work. So we can say that the domain is everything except x equals 1. And I can just note that as x is not equal to 1, or I can say it's negative infinity to 1 and 1 to infinity. However you want to notate that domain, as long as you communicate that it's everything except x equals 1. Now for the range, we start by assuming that it's everything, and then think about what would happen to your horizontal asymptote as we shift the graph along its vertical shift. So in this case we have a vertical shift of 1, and that's going to move that horizontal asymptote up 1. So our range is going to be everything except y equals 1. That's the only value that's not going to be within the range of this function. Now notice that the range creates the horizontal asymptote, and the domain creates the vertical asymptote. Oops, let me go back for a moment. So our horizontal asymptote is at y equals 1, and our vertical asymptote is going to be at x equals 1. Now let's take a look at f of x equals 3 divided by x plus 1 minus 2. We want to identify the domain and the range, and we start by assuming everything, and then we're going to want to identify the horizontal and vertical asymptotes. So what is going to give us a 0 in the denominator? And the answer is that a 1 would give us that 0, so the domain is everything except x equals negative 1. I apologize, negative 1 will give us a 0 in the denominator. Now the range, when we shift our entire graph and its asymptotes, is going to go down this time, so the range is going to include everything except y equals negative 2. This means there's going to be a horizontal asymptote at y equals negative 2 and a vertical asymptote at x equals negative 1. And we know that whatever we do, our rational function has to look like this business in the corner. So I make my horizontal asymptote at negative 2, I draw a dotted line there, and I make my vertical asymptote at negative 1. Now, I know that my parent function usually goes through the point that's 1 over and 1 up from my asymptotes, but this time I've got a function that is 3 times as tall. So instead of going over 1 up 1, I know that that point is going to be over 1 and up 3, and to the left over 1 and down 3. So when I go to draw the graph, I'm going to go ahead and place those 2 points in there and then just connect them with the branches how I know they are. Now your asymptotes are in the right spot and your corner points are in the right spot, so that's probably a good looking graph.